Okay, here we go. So today we're going to graph sine and cosine graphs. Sine again, and cosine. But we're going to talk about our period, and we're going to talk about our horizontal shift. Actually, our period we're going to say reference frequency in 2 pi. Frequency in 2 pi. Now, we talked about before our standard equations for sine and cosine is y is equal to a sine parentheses bx minus c plus d. Sometimes the book will describe this as a plus c, depending on the book. And y is equal to a sine, sine, I just said sine. A cosine of bx minus c plus d. As you can tell, they have the same characteristics of the a, b, c, d. A, b, c, and d. And these four characteristics change the way the graph looks. Whether the amplitude changes, the period changes, the frequency, the horizontal shift, the vertical shift. So we'll describe them all again. A refers to my amplitude, and it's how high and how low your graph goes. So if I say this is positive 1, A is equal to 1. But if I say my B value, my A value, sorry about that. When my A value is 1, we're up here, and A value is, we go up 1 and down 1. And then if my A value was 3, negative 1, 2, 3. I draw these little dotted lines to help me keep my graph in line. So we'd be up here, 0, down, 0, up, down. So what is amplitude? If you're into music, if you know anything about music, amplitude is more like raising your volume really loud. The beat doesn't change, the octave doesn't change, but the volume does change. It gets louder. And then if I want to make this very quiet, I could put my A value as 1/2, and then that would be, if my A value is 1/2, we'd be right in the middle. Darn it. If it was 1/2, we'd be right in the middle here. And we would have a little tiny wave here. Let's see that. Okay. We talked about our D value, our horizontal shift. No, vertical shift, I'm sorry. Our D value was our vertical shift. And if it was sine, y is equal to sine of x plus 2, the whole graph, instead of being down here, would be lifted up 1, 2, and this would be the new center of my graph, and it would be up like that. If it was y is equal to, let's do a different color, y is equal to sine of x minus 2, 1, 2, would be down here. It's the same graph. If all the little letters remain constant, A, B, C, and only D changes, that means that it goes up and down. It's a vertical shift. let's continue. So today we're going to talk about our b value. And our b value is, we say refers to period because its period is 2 pi over b. So we use b to calculate our period. Now, the way I understand period, the way I like to talk about period is how long is your interval? Let's say you're taking some Tylenol, and the bottle says you take it every 6 hours. Is that a period or is that interval? No, is that a period or is that frequency? Period or frequency, I'm sorry, period or frequency. This is the period. This is how long. This is the interval. That's how long you take it in 24 hours. So 24 hours. Every 6 hours, you have to take it again. But what is the frequency? How many times do you have to take it? Frequency in a whole day, in 24 hours. And you can see it's 1, 2, 3, 4. We're going to take it 4 times. 4 times. And that's our frequency. And our b value is in fact frequency. So, using this example, if I'm looking at a 24-hour period, and I have to take medicine 4 times, that's the frequency, in 24 hours, how long do I take the medicine between each dosage? We take our time period, we divide it by the frequency, we take our time, we divide it by the frequency, and then we end up with our period. 6 hours. Now, why don't we graph frequency? Why do we graph period? Well, here's the obvious reason why. If I told you this is 2 pi, and I said graph sine of 2x, this a, b, and then no c, and then no d. B is frequency, so I see my b value is equal to 2. That means I'm expected to see this graph happen twice in 2 pi. Well, fine. In that case, am I supposed to just squeeze in randomly like 2 and just hopefully I get lucky? If your doctor told you, take this medicine 8 times a day, what does that mean? 8 times. Do you think it's easier for you just to manage 8 times? Or is it easier for your doctor to tell you, take it every 3 hours? So I think when it comes to us graphing, period is actually more useful because it tells us the length, 2 pi over b, and our b value was 2. That means I need to stop by pi. So at pi I go half, half, and half. So now I know about half, half, and half about the length of my graph. Okay, so let's put this into practice. Let's go ahead and graph something. Let's say y is equal to, again, let's do cosine this time. Let's do 3 cosine of 2x. So a is equal to 3, b is equal to 2. Do we have a c value? Do we have a d value? Answer is nope, nope. Those are both at 0. So c is equal to 0 and d is equal to 0. Because there's nothing here. No parentheses. Remember, it's a cosine of bx minus c. No parentheses, no c, and no d value because there's no number by itself. Okay, so let's go and graph the characteristics. We graph dCVA. D is 0, so we're going to graph 0. My C is my horizontal shift. We have no horizontal shift, so we're going to start off at 0 here. B is the period, so we have to use P is equal to 2 pi over B, which is 2 pi over 2. The 2's divide out. You guys all see that? The 2's divide out. And we're left with pi. So I need to stop my graph by pi. Now, like I did before, I always draw my half, half, and half tick marks. Half, half, and half. And that nicely spaces out my graph. If you see, that's not amazingly great, but it's good enough. And if you want, you can label it pi over 2. Half of that is pi over 4. Now again, half of pi is like 50 cents. Half pi. Half of 50 cents is a quarter. Pi over 4. If I count 1 quarter, 2 quarters, 3 quarters, and 4 quarters. Will that line up? 2 pi over 4 is just 1/2. 4 pi over 4 is just pi. And then we go ahead and so now we have our last letter A, which is amplitude 1, 2, 3, 1, 2, 3, and then I always end up drawing our little nice dashes because I need this framework all laid out, so I don't have to think about am I going high enough, am I low enough. Now this is a cosine graph. We talked about cosine graphs before. Sine graphs start off at 0. Cosine starts off at 1. And then back to the unit circle. If I look at the unit circle, cosine is x, sine is y. So let's call this theta. It's okay. Oh, fine. Oops. Cosine is x, sine is y. Okay. On the unit circle, at 0 degrees, the x is 1, the y value is 0. Let's take a look here. The x value is 1 for cosine, and the sine graph, when x is 0, the y value is 0. Let's move on. Up here, so let's write this as cosine. Oh, this is sine. It's cosine. Again, this is just reiterating what we talked about before. 0, 1. So the cosine is our x value. So at pi over 2, right here, my cosine is 0, and at pi over 2, my sine is 1. Over here at pi, it's pi, it's pi, it's 2 pi, 2 pi, -1, 0. So my cosine is -1. See, I'm at the bottom of my graph. And the y value is... Okay. Just walking around the circle. Okay, let's go back. So we're looking at cosine. Cosine starts at 1. That means we go all the way up to my amplitude, going down to 0, -1, 0. When I say -1, it's really -1 times the a value 3, the amplitude. And this graph continues. We can make the nice tick marks. Give yourself some space. These graphs keep on going. They don't stop. But our main goal is to be able to draw one iteration at least. Draw one iteration. Okay. What if y is equal to negative 2 sine, let's say it's 1/2 x. What if b value was 1/2? So imagine if I told you the frequency is 1/2. Imagine if I told you I only finished not all my homework in one day. I finished only half of my homework in one day. So how long would it take me to finish all my homework? 2 days. C is equal to 0. D is equal to... Make sure you label all these out. A, B, C, D. So graph again. D is 0. And my C value is 0, so we're starting at 0. We have a period is equal to 2 pi over b, which is 2 pi over 1/2, which we multiply by the reciprocal. 2 pi, I'm going to write that one time and one time only. That's 4 pi. It takes me 4 pi to finish. So whenever I graph my period, I then cut it in half, half, and half, because this gives me my spacing. Half, half, and half. The half of 4 pi is 2 pi. Half of 2 pi is pi. And if we're counting, 1, 2, 3 pi, and then 4 pi, right? And then we said the sine is amplitude is negative 2. Well, what that means is it's still going to go up 2 and down 2, except it's going to flip my graph. All my positive values, when I multiply by negative 2, become negative. And all my negative values here, when I multiply, negative times negative becomes a positive. So our graph gets flipped. Let me just draw that graph again. Going through all the steps, D value is 0. A C value is 0, so we're starting at 0. My period we said was 4 pi. And it's pi, 2 pi, pi, and 3 pi. We said my amplitude is going to be 2, 1, 2, 1, 2. So we'll make dots on the top and on the bottom. Let me go ahead and switch those colors. Change that color. Then we're going to go ahead and label, since this is sine, we start at 0. And negative 2, instead of going up, we go down. 0, up, 0. Because it's a negative amplitude, we end up multiplying our function by a negative. All my positives became negative, right? All my positives became negative, and all my negatives became positive. All my positives became negative, and all my negatives became positive. Now, what we mentioned before, we said my b value is 1/2, and b stands for frequency in 2 pi. So how much of our graph did we see in 2 pi? Did we see the full graph, or did we see half of it? And it looks like we just saw half of it. We needed another 2 pi to finish. Okay, well, the next hardest part here is really graphing our C value. C is where everything kind of comes over. So let's do something kind of a good start. Y is equal to sine of x minus pi. So a is equal to 1. b is equal to 1, c is equal to pi, and d is equal to 0. Now, why did I choose pi? And why didn't I choose negative pi? If you remember, when we first started, we talked about our form is a sine bx minus c plus d. Now, c is already negative. C is already negative. And if c is already negative, if I just plug in pi there, it becomes, so c is pi. Oh my gosh. Okay, so we'll graph it as we see it. D is 0. Now, C helps us find our vertical shift. Sorry, it's not vertical, I'm sorry. Horizontal shift. So what we're going to do, we're going to say x, which is my horizontal shift, is equal to b over c. So my b value is pi, and my c value is 1. Now, that might sound kind of weird. So why is it like that? This might sound kind of weird. So why is it like that? Now, if you remember in Algebra 2, we had vertex form, and it would go something like a x minus h squared plus k. We talked about this before. And you're always trying to make that go to 0. And that's our horizontal shift. So for instance, if it was x minus 3 squared, my x value would be positive 3, because that's what would make this go to 0. If you remember when we were factoring, write 2x plus 3, and let's say x plus 2. X would be negative 3 over 2, and negative 2. We would make them both go to 0 and 0. The same thing happens here. The sine of x minus pi, we're trying to make that go to back to 0. Because what is the sine of 0? That's 0. That's for us to restart, because my sine graph starts at 0. So what x value would restart my graph? Well, in this case, x minus pi would be x is equal to pi. Or, if let's use the letter sine of bx minus c. Bx minus c would become 0 when x is equal to c over b. Oh my goodness. I flipped this around up here. I'm sorry. I made a mistake here. I'm sorry. This here is wrong. It should be changed to c over b. And I wrote that. I just didn't write the letters correctly. It's c over b. Sorry about that. C over b. And that's why that's our equation. So how does that affect our graph? It means we start off not at 0 anymore. We start off at, let's say that's pi. And you can put pi anywhere you want, where your starting value. But just make sure you're aware that if I put it in the wrong spot, it's going to be a harder graph. Okay, here we go. Our next value b tells us our period, 2 pi over b, which is 1, which is 2 pi. So since we started off at pi, we won't finish till 1. Okay, that's 1 pi, and we're going to 2 pi. That's 2 pi, and that's 3 pi. Again, we're just counting. if, let's say, I have homework to do, and homework's going to take me 2 hours. If I start homework at 12 o'clock, I won't be finished till 2 o'clock. But if I start homework at 1 o'clock, I won't be done till 3 o'clock. So you always have to shift over depending on where we start. Okay. So we have our starting, we have our ending value, and then we go half, half, and half. And that always gives us that spacing. Always gives us a spacing for when this graph should start and stop. Our amplitude is 1, up 1, and minus 1 from 0. I'll draw that with a blue color. Hope you guys see that. And since we said we're going to start off at pi, this is sine graph. Sine graph starts at 0. The sine of 0 is 0. 0, up, 0, down, 0. 0, up, 0, down, 0. Well, what about the rest over here? What about the rest of the graph? What about the rest? Well, remember the graph keeps on going. So as long as I keep those tick marks, and we look here, those tick marks are pretty important. If I keep those tick marks, we can continue the pattern. So C introduces a horizontal shift, but it's not as clean as A and D. B introduces a period change, but again, it's not just taking it as a straightforward value. You have to use the formula 2 pi over B. So again, period, so our B value is 2 pi over B. And C introduces a horizontal shift, and it's going to be X. The start of my graph is C over B. Let's do one more. Let's do one more of these problems. This time we're going to include everything that we've done already. So let's do y is equal to 2 sine 1 over 4 x, let's open parentheses, minus, I do pi over 2, this looks terrible, plus 1. Okay. We label, like always label A, B, C, D till you get really good at this. A is equal to 2, B is equal to 1 over 4, C is equal to pi over 2, and D is equal to 1. Double check that for me. A is in front, B is always next to X, C is in the parentheses, the negative sign is already there, and D is by itself. So, make a bigger graph here. D, automatically we know it's 1. That's super easy. That's my vertical shift. C helps us find our horizontal shift, tells us where our starting value is, but remember this is done by X is equal to C over B, which is 2 pi over 2 divided by 1 over 4, which means we multiply by the reciprocal, which is 4 over 1 times pi over 2, which is 2 pi. Turns out I'm going to start at 2 pi. Not only do I start at 2 pi, well, how long is it going to take me to finish the graph? Well, in 2 pi, we only finish a fourth of my graph. So how long is it take me to finish the full graph? Well, P is equal to 2 pi over B. Just stick to the equation. P is equal to 2 pi over 1/4. When I divide by 1/4, I really multiply by the reciprocal. So it's actually 4 over 1 times 2 pi, which is 8 pi. Oh my gosh, it's taking me 8 pi to finish. Well, if I start at 2, I won't finish all the way to what? 2 pi plus 8 pi is 10 pi. Oh my goodness, that's so far away. That's fine. If we can count by, we know this is 2. And this is going to be 4, 6, draw the line longer, 8, 10. Half, that's half, which is, what's halfway between 2 and 8? 2 and 10. 2 plus 10 is 12. Divide that by 2 is 6. That's 6 pi. 2, this is 2, 4, 6, 8. And that kind of works out, right? 2, 4, 6, 8, each of those tick marks. Yeah, let's clean all this stuff up. So we know we're going to start and we're going to end. We have a halfway mark. Okay. Oops. I'm going to make that D value just a little nicer and mark it all the way out. Okay, we did D for our vertical shift. We know the graph is one space higher. We did our x value. We know that x value, we're starting right here at 2 pi. We know we stop 8 pi later, so 2 plus 8 is 10 pi. We did a half, half, and half, so we know our spacing. And the last part we gotta deal with, oh sorry, we have to then copy our tick marks up here. Remember, because we shifted our graph up 1. And now our last value is our A value. So A is from our center here, go up 1, 2 spaces, and then down 1, 2 spaces. Remember, that's the amplitude. Let's clean that up a little bit. So 2 spaces up, 1, 2 would be 3, and that is our amplitude on top. Down 1, 2. And that's our -1, because 1 minus 2 is -1. Right? This is a sine and cosine graph. Remember, sine graphs always start at 0. Cosines always start at 1. And since our race starts here, our graph is going to be a sine. Second tick mark goes up. Third tick mark reset back to 0. Fourth tick mark go all the way down to the amplitude. And the last tick mark back to 0. Graph reset. The graph is ongoing. Now, what do I do with this section here? Well, look at it. How much space is that section? Would you say that's about 1 tick mark? Or is that more than 1 tick mark? Is it less than 1 tick mark? So if I looked at the tick mark here, that's 1 tick mark. This should be 1 tick mark. Did I get to do 1 full loop, or is it just half? Didn't we just go up here and I see a tick mark? So going backward, going the other way, we would actually go down over here. And this graph would continue this way. And this graph would continue this way. Right? Okay, hopefully that was helpful. If you need more examples, let me know. I was trying to get IXL working for you guys, but I'm waiting for them to switch the account over, or for Miss Hurst to take over. But hopefully that was helpful. If I can post something, or if you guys want me to post some practice problems, there's actually a lot of problems in your book that you can look at. The chapter that we assigned before we went on break, that section is all about graphing these graphs. I'll stream again for this class, unless if they tell me Miss Hurst will be taking over on Thursday at 2 o'clock. Okay? We'll do A and B days at 2 o'clock. Okay. Thank you.